All right, so this problem is on the horizontal accelerometer. You're going to be using one of these on our Six Flags trip. So say you get on Superman the Ride, and before the car takes off, your horizontal accelerometer looks like this. It's a protractor with a mass hanging straight down like this. And it doesn't matter what the mass is, because you'll see when we set the problem up, M is going to cancel. So it could be a little mass or a big mass. I recommend something larger, because then wind resistance won't be as much of a factor. If you stick on like if you put a paper clip on the end of the string, air resistance will be a huge factor. So make this something kind of meaty. Okay, so the ride takes off. What happens is the string on your horizontal accelerometer swings back. So 25 degrees, so that's 90 right there. So 80 is 10, 70 is 20, so it's be right through there. That would be a 25 degree swing. So now the mass is swinging back like that. From the starting position is right there. From the starting position, it swings back 25 degrees. From that angle, you can figure out what your horizontal acceleration must be. And here's how you do it. The first thing you do is free body diagram for the mass. So you got this mass hanging like this, and there's two forces on the mass. You have mg pulling the mass straight down, and then you have tension in the string that's at an angle. Now here's the thing, guys. Look at this. Look up here. This 25 degree angle is off the vertical. See that? Look, see this line right there? That's the vertical. Typically, you want to use your angle off the horizontal. Most people find that easiest. So if that's 25 degrees, so I just made a triangle here, there's a right angle there. So what angle would this have to be? If that's 25 up there, then this has to be what? 65, right? Because all the angles add up to 180. So this angle in here on the free body diagram would be 65 degrees. So any questions? Now, as you probably know at this point in the class, or I should say you definitely should know this, in physics a very common thing is to separate the x and the y, because they don't affect each other. They're completely separate from one another. Now the thing that makes this situation slightly tricky, for regular physics, so for somebody watching the video, if you're in AP physics, this is not tricky at all. But look, this tension right there, is that tension perfectly in the x direction? No. Is that tension perfectly in the y direction? No. So what we have to do is break that tension into what we call components. So this is x component, that'd be t sub x, that'd be t sub y. Now how do we get tx and ty in terms of t? By using trig. Okay, so for example, t sub x is going to be cosine 65t, and then ty is sine 65t. Now let me show you where I got that. Let's do tx. So if you look at cosine of 65, so what's the definition of cosine? Adjacent over hypotenuse. So what's adjacent to the 65? Tx. What's the hypotenuse? T. So if you rearrange that, you get Tx equals cosine 65t. You guys follow that? And then for the y, just do the same thing but with sine. Sine 65, sine is opposite over hypotenuse. Okay? So that's the free body diagram. So the next thing we're going to do, after a free body diagram, we sum the forces. So we're going to sum forces x, and we're going to sum forces y. All right, in the x direction, there is only one force, and that is Tx. There's only one force acting in the x direction. It's the x component of T. So that is cosine 65t. Now, what is the sum of the forces always equal? ma. Now, does that a go to 0? No, it does not. Because if you think about this mass here, what's this mass doing? Accelerating to the right. When you're sitting on Superman the ride, what are you going to be doing? Accelerating. What's that hanging mass going to be doing? Accelerating. Would everybody agree that that mass is accelerating to the right? Yeah. Okay, so don't cancel that A. Now, in the y direction, what forces do we have in the y direction? We have Ty and mg, right? So you're going to go sine 65t minus mg. Any other y forces? No. Nope. So that equals ma, or that's a y acceleration, right? The first a was an x acceleration. Now, this y acceleration, is our mass accelerating this way? No. Is there any acceleration in the y? No. Nope. So what can we do to that y acceleration? Cross it out to 0. All right, we have two equations, two unknowns. What are the two unknowns here? T and A. Those are the two unknowns, okay? So we can substitute. So here's what you do. So take, I don't know, what should we do? Solve both of these equations for t. Oh, and by the way, a little math help. What is sine over cosine? Tangent. We're going to need that. That's going to simplify it. Sine over cosine is tangent. So take this first equation, solve it for t. T is equal to ma over cosine 65. And then take this equation, solve it for t. Take that equation. T is equal to mg over sine 65. Okay, so look at, what do we know about those two tensions? They're the same, which means this and this must be the same. So you got ma over cosine 65 equals mg over, I'm probably making this harder than it has to be. The m's cancel, see that? The m's cancel, so a is going to be equal to g times cosine 65 over sine 65. So that's the same thing as g over tangent theta. Tangent 65. So that comes out as, so you plug in for g. G is 9.8. Tangent 65. And you get 4.6. So basically, like, you can do the algebra, but the physics part is you got to do your free body diagram, sum the forces. Once you have the forces summed, you can solve for A.